Hello viewers, in today's session we are going to discuss an important inequality from application of derivatives, right? And here we are going to prove this inequality, which is sine of cos x is less than cos of x, and it is further less than cos of sine x for all values of x belonging to this open interval, that is 0 to pi by 2, right? So in this session we'll prove this important inequality using the concept of increasing and decreasing functions, right? And this problem is going to be a very easy problem, but here we have to make use of some simple concepts, right? So let us start. So here we'll start with this function. Let us take f of x is equal to x minus sine of x, right? So here we'll take this function f of x is equal to x minus sine x, which is defined in this interval, that is x is greater than 0 but less than pi by 2, right? So here first we'll derive the inequality, that is x is greater than sine x for all values of x belonging to this interval, that is 0 to pi by 2. And remember, x is a real number, right? So here we have this function, so let us differentiate this function. We will get f prime of x, and the derivative of x is 1. Then we have the derivative of sine x as cos x. So now for this function to be an increasing function, that is f of x is increasing when the derivative is positive, that is derivative is greater than 0. So it means we have to prove that 1 minus cosine x is greater than 0. Now see, when we take this interval, that is 0 to pi by 2, then the cos function, that is cosine x, it lies between 0 and 1. Because see, when we take x greater than 0 less than pi by 2 and we take cosine throughout, then we have the inequality, that is cos of 0 is greater than cos of x greater than cos of pi by 2. So here the direction of the inequality get reversed, because cosine function is a decreasing function in the interval 0 to pi by 2, right? So cos 0 is 1, and here we have cos of x, and cos pi by 2 is 0. So we can also write this inequality like this, right? So cosine x lies between 0 and 1 when x lies in this interval 0 to pi by 2. So it means 1 minus cosine x is always greater than 0, because this term cos of x is always going to be less than 1. So we can see that this derivative f prime of x is always going to be greater than 0 for all x belonging to the interval 0 to pi by 2, right? So we can now say that f of x, this function, is an increasing function for all x belonging to this interval. So we have proof that this function f of x is an increasing function in this interval. Now let us quickly see the definition of strictly increasing function. Here we have x-axis, here we have y-axis. Now suppose a function y is equal to f of x is a strictly increasing function, then the graph, we can draw the graph like this. And if we take 2 points on this curve, then this point is x1 and this point is x2. So this distance is f of x1 and this distance is f of x2. So the definition of strictly increasing function goes like this: if x1 is less than x2. So here this x1 is less than x2, then f of x1 is also less than f of x2. So this distance, that is this ordinate or the y coordinate, are f of x1 and f of x2. So when x1 is less than x2, f of x1 is also less than f of x2 for a strictly increasing function, right? So here I will use this concept, and we'll take x1 is equal to say 0 and x2 is equal to x, right? So here we have this inequality, that is 0 is x is greater than 0. Now this 0 is our x1 and this x is x2. So by this definition, f of x1 must be less than f of x2 when x1 is less than x2. Now f of x1 can be obtained by replacing x by x1. So we have x1 minus sine x1, and here f of x2 is given by x2 minus sine of x. Now x1 is 0, so we have 0 minus sine 0, and here we have x2 x, so we have x minus sine x. So sine 0 is 0, so 0 minus 0 is equal to 0. So we have x minus sine x is greater than 0, right? So we can now write, we can take this sine x to this side, so x is greater than sine x. So we have derived this inequality, that is x is greater than sine x, for all x belonging to this interval, that is 0 to pi by 2. So now let us come to our inequality which is to be proved, right? So we'll prove this inequality in two parts. So first we'll prove that sine of cos x is less than cos of x for all x belonging to this interval 0 to pi by 2, right? So for proving this inequality, what we will do, we'll take help of this one, right? See, we have just proved that sine of x is less than x for all x belonging to 0 to pi by 2. Now see, this x is a real number which lies in this interval, that is 0 to pi by 2, right? Now see, here we have 0 and here we have 1 and here we have 2. Now pi by 2 is 3.14 over 2, that is 1.57. So this is approximately 1.57. So pi by 2 lies somewhere here. So now our x, which is a real number, it lies in this interval, right? In this interval, excluding 0 and pi by 2. And see, if we replace this x by cos of x, right? See, x is a real number, cosine of x is also a real number, and this x lies in this interval, that is 0 to pi by 2, in the open interval 0 to pi by 2. So now we are replacing in this inequality x by cosine of x, because this inequality is valid for all values of x which lies in this interval, that is 0 to pi by 2. And when we replace this x by cosine of x, then we'll get sine of cos of x is less than cos of x, and we get this inequality. Now see why we have replaced this x by cosine x, because our cosine x, it lies between 0 and 1, right? So the cosine function, that is cos of x, where x belongs to this interval, that is 0 to pi by 2, then we can take this substitution, that is x is replaced by cosine of x in this inequality. So now the replacement of x by cosine x can also be understood in this way. That is, if we take cos of x as theta, right, where x belongs to this interval 0 to pi by 2. So now this inequality gives us theta greater than 0, but it is less than 1. And here we are taking cos of x is equal to theta. So it implies that this theta, that is cosine x, it lies between 0 and 1, right? And this inequality is valid for all values of x belonging to the interval 0 to pi by 2, right? So this number cosine of x can be replaced by this x. So we get sine of cos of x that is less than cosine of x. So in this way we get this inequality. Now let us prove this inequality, that is cos of x is less than cos of sine x, and then I will combine these two inequalities. So now again we can prove this inequality by using this one. Now see, we are given x greater than sine of x, right? And let us take cosine of both these sides, that is cos of x, and here we can take cos of sine x, right? So what we have done, we have started with this inequality, x greater than sine x. Now we are taking a cosine of both sides. Now we get cos of x, and here we get cos of sine x. Now the direction of this inequality get reversed. Why? Because this cos function is a decreasing function in this interval, that is 0 to pi by 2. So cosine function is a monotonically decreasing function in the interval x greater than 0 and pi by 2. So that's why the direction of the inequality get reversed. So this is how we can prove this inequality by taking cosine of both sides, right? So now we have these two inequalities. So here a cosine of x is greater than this one, and here a cosine of x is less than this one. So if we combine 1 and 2, then we can easily write sine of cos x. Sine of cos x is less than cos of x, and this cos of x is further less than cos of sine x. And remember these x belongs to this interval 0 to pi by 2. So this is how we can prove this inequality. So viewers, from this problem we have seen a lot of concepts, and we have derived this inequality, that is x greater than sine x, and with the help of this inequality we have proved sine of cos x is less than cos x, and cos x is less than cos of sine x, and then combining both these two we get this inequality.